Welcome back to Database Management System classes. In the last class, we started with the discussion of entity relationship model, and today we are going to discuss about the extended entity relationship model features. The topics that we are going to cover today is how to reduce year diagrams to relational schemas. What are the extended year modeling features, entity relationship design issues, alternative notations for modeling data, other aspects of database design. So, starting with the first concept, that is how to reduce to relational schemas. That means we have the entity relationship diagram from which we are going to convert it into a relational schema. That means a logical representation of the entire year model that can be converted into actual database. Entity sets and relationship sets can be expressed uniformly as relation schemas. That means when we are going to design our database, then the entities and the relationships can be converted into relation, and relation means tables. A database which conforms to an year diagram can be represented by a collection of schemas. For each entity set and relationship set, there is a unique schema that is assigned the name of the corresponding entity set or relationship set. Each schema has a number of columns, generally corresponding to attributes which have unique names. Now, let's brief you about this interpretation of year diagram into a database schema. Fine. A strong entity set reduces to a schema with the same attributes. Let's say here we have the course, that is a table. Here I have highlighting this particular table, course table. Now this course table is going to be created in the database, and the graphical representation in the year model, it is like this. This is the relationship, that is course means section and course. This is the table for the database implementation, course and section. So these are the two entities which will be converted into these tables in the database. Now, representation of entity sets with composite attributes. We discussed about composite attributes. Composite attributes are nothing but that can be reducible to meaningful subparts. So here name is the composite attribute which has these three different subparts. Similarly, the address is also a composite attribute which has street, city, state and zip. These are the different subparts, out of which the street is also again a composite attribute which has these three parts: street number, street name and APT number, apartment number, street name and street number. Okay. So this is the discussion of composite attributes that can also be created in a database. Now, representation of entity sets with multi-valued attributes. So in the database, we can also input multiple values of an attribute. Let's say, for example, this is an INST phone. So the phone number can be more than one. So that particular column with phone number field may have more than one value. So that is why it is called as multi-valued attribute. Okay. So this is the representation of multi-valued attribute. Now representing relationship sets, how the relationship sets can be represented, that is important. In year diagram we have, let's say, instructor is a entity and student is another entity. Now instructor advises the students. So this is basically nothing but year diagram representation where it has two entities and one relationship. The name of the relationship is what? Advise. Advisor is the relationship name here. Now instructor and students, they are two entities which are involved in a relationship called advisor. That means instructor advises student. So this is the relationship name in a diamond shape. Now this is a binary relationship because two entities are involved in this relationship. That is why we can say it as a binary relationship. But one instructor instructs many students, that is why it is one to many. If it is so that many instructors instruct many students, in that case it is many to many. Okay. Now let's discuss about the redundancy of schemas. Redundancy means if schema contains many to one and one to many relationship sets that are total on the many side can be represented by adding an extra attribute to the many side containing the primary key of the one side, right. Let's elaborate it with an example. Instead of creating a schema for relationship set, here inst dpt, this is the relationship set which combining these two entities, instructor and department, these two entities are combined with this relationship name as inst dept. The next one is stud underscore dept, which basically combines the department and student. Okay, this is the student and this is the department, and it is combined by this stud dept relationship. Similarly here the instructor advises the student, so this is another relationship like this. Now how they are redundant means there are three relationships, right, and we could draw three different diagrams to represent this particular representation, where instructor department, then department student, then instructor student, we could put it in three different diagrams. But here what we have done, we have combined all these binary relationships. Here also it is a binary relationship representation, but it is in the under the single diagram. So this is how we can reduce the redundancy of the schema. Let's move on. So redundancy of schema for one-to-one relationship sets, either side can be chosen to act as the many side. There is an extra attribute can be added to either of the tables corresponding to the two entity sets. If participation is partial on the many side, replacing a schema by an extra attribute in the schema corresponding to the many side, that could result in null values. Okay. So now we are going to put light on the extended year modeling features. To start with specialization, there are three more things to understand, that is generalization, aggregation, and inheritance and objects. So these are the four features that extended year modeling covers. So starting with the specialization, So specialization is a process, we can say it is a top down design process. Very simply to tell you, let's say person is an employee, so the person is a generic thing and employee is a specialization, right? Like instructor is a person, so person is generic whereas instructor is special, or we can say specific. So this is the very basic example of specialization. So to make it more clear, we can give more example later on. So here we need to understand the concept of attribute inheritance. A lower level entity set inherits all the attributes and relationship participation of the higher level entity set to which it is linked. Let's discuss whatever we told just now with a diagram. Here you see person is an entity and employee and students are of type person, and you see here that employee and students are special, means they are specific in nature. If a person is a student, like he can also be an employee somewhere. So we can say these are overlapping, but instructor and secretary is disjoint specialization, means if an employee is an instructor, so at the same time he cannot be a secretary as well. Okay, so this is called disjoint specialization. So to denote this, we write a circle and inside which we type D, and a person could be an employee as well as he can be a student as well. That means this person set is specialized as student as well as employee, but if there is some overlapping, means some person is employee who is also a student, in that case it is called overlapping specialization. So within circle we write O over here. So that is the representation of overlapping specialization. So there are two types of specialization, one is overlapping, another is disjoint. Now coming to the next understanding of specialization via schemas. So here is an example of a schema and with their attributes. So first schema is the person, it has some ID, name, the address for street and city. Then student, it also has ID, the total credit. Then the employee has ID and salary. Now form a schema for the higher level entity, that is the first step. Next, form a schema for each lower level entity set, include primary key of higher level entity set and local attributes. But here there is a drawback. The drawback is that getting information about an employee requires accessing two relations, the one corresponding to the low level schema and the one corresponding to the high level schema. Now we are moving to the next method. For a schema for each entity set with all local and inherited attributes. So this is what the local and inherited attribute which we have here, but here also we have a drawback. The name, street and city may be stored redundantly, means every schema, student schema, employee schema, everywhere we see the name, street, city, etc. are repeated, and which is not necessary. That is why it is called redundant. So this method is not also good enough. Okay. Now coming to the generalization, it is a bottom-up design process. So specialization where there is some problems, so to rectify that we will discuss about the generalization as well. So a bottom-up design process which combine a number of entity sets that share the same features into a higher level entity set, like person and employee. So person is the higher level and employee is the lower level. Okay. Person is more generic, which will not store any specific information but very generic kind of information, the name and address, right? Whereas employee will have only employee ID or in which company he is an employee, this information, specific information. Similarly, for student, it will have the student roll number and in which institute he is admitted. So these are specialization attributes, but generalization where it will have the name, the generic address, etc. So this is how the generalization is termed as or understood. Now it is also a very important concept here, completeness constraint. It specifies whether or not an entity in the higher level entity set must belong to at least one of the lower level entity sets within a generalization. Now that could be a total or it could be a partial. Total means an entity must belong to one of the lower level entity set, and partial means an entity need not belong to one of the lower level entity set. Means, say for example, person is the higher level entity set, whereas the employee and student, they are the lower level entity sets. Now all person cannot be an employee, right? But maybe all person was a student or is a student. So all the person are totally participating in the lower level entity, but some person are participating in the employee, that is lower level entity set. So single line denotes the partial participation, whereas double line indicates the total participation. So this is how it is trying to understand, we are trying to understand the completeness constraint. Now partial generalization is the default, means any entity that is represented with a rectangle, it is connected with another entity in a single line. Okay. Now this is the way how we are representing the specialization. The arrow, the sharp side of the arrow which is connected to the entity, that means that is the specialized or lower level entity. This way the arrow is denoted. So this is the entity which is generalized, and at this side whatever entity is there, that is specialized. Okay. Now this is an example of aggregation relationship. I started with the extended ER modeling features where I mentioned about the aggregation. Aggregation means, let's suppose there is a ceiling fan which comprises of blades, then coil and many other parts. So each part is an entity and all these entities combinedly forms the ceiling fan. So what it means, the aggregation means a sub-part relationship. So has a relationship, ceiling fan has blade, ceiling fan has coils, like that. So that is the easy representation of aggregation relationship. It is different from aggregate function in relational algebra. So don't get confused with these two terms. One is aggregation relationship in ER modeling and another one is aggregate function in relational algebra. So that part we will discuss later in the understanding of relational algebra there. So now here this is an example how this aggregation is denoted. So a rhombus kind of representation is done in between these two set of entities, which is instructor and student, and there is a rhombus means aggregation eval for evaluation. So evaluation is an entity which is a combination of the instructor and the student. Student participates in the exam and instructor evaluate him or the student, and then the evaluation result comes out. So evaluation is an aggregation of the instructor and student. Similarly, project is also is a combined effort of instructor and student. That is why project guide is the relationship name, which is a kind of aggregation and that sums up to the project. So the same discussion that I have explained right now, that is elaborated here, you can just have reference from here. Now this is a diagram that can be represented in an aggregation form. So evaluation is the final entity here, this one, which is coming from the evaluation part, and this part is project evaluation or project guided by thing. So this entire thing is, we can consider a complex entity which is the aggregation of this evaluation, means in aggregated way we are finally getting the evaluation result. Okay, so this is aggregation relationship. Now coming to the reduction to relational schema, it is a very easy concept to understand. Like if an entity contains some attributes, let's say eval for is the table name or entity name, and that has these many number of attributes. So this is the way how we can put them in the schema. So this is the schema representation of the entity in a ER model. So design issues, some common mistakes are made while depicting the ER diagram, and that should be corrected. So in the figure A, you can see here some common mistakes like this. This is an entity and this is another entity, and you see here in the student there is department name, and also in the department there is department name. So redundant information is there, which is easily avoided, but unnecessarily they are kept in two places. Similarly here, student section where we are putting the assigned marks, which is also not correct. So this kind of mistakes should be avoided. Now here student section is having this particular entity, but this cannot be here. So this is an erroneous representation for wrongly putting the entity connected with some wrong relationship. And this particular place, student marks in assignment and section. So this is the correct alternative, but here also we can see that it is little bit lengthy, right? So that is why we can further modify this particular thing, and finally we can correct it in a better or optimized way. And this is the representation where we can say that this is more sensible design than before. And here entities versus attributes. So this is an entity instructor which has 3 attributes, one after another, ID, name and salary. And instructor phone number is the relationship, where phone number we are putting it as a separate entity, where we are putting the phone number as well as the location. So this way, if we design, that will help us to put some extra information of the phone number, and we are also allowed to put multiple phone numbers here. Now coming to the discussion on entities versus relationship set. Here in a single diagram we can see that registration is an entity where there are two relationships, section registration and student registration. Section registration is connected with a entity which is called section, and student registration is also connected with a entity that is called student. So this is how the entities and relationship sets are connected. Okay, so binary versus non-binary relationship. That means if there are more than two entities which are connected to each other, that is called a ternary relationship, that we can convert into binary for simplicity. Here our main concern is that, so if we can convert ternary relationships or quaternary relationships into binary one, then that could be easily understandable. So how we can convert the non-binary relationships to binary forms? So taking this first example here, there is a relationship R which is connecting three different entities. Now to convert it into a binary one, what we do is that converting R into three different relationships, and in place of R we are putting E as a new entity. So with this E entity, which will be totally participating in three new relationships, RA, that is connecting this E entity with an entity A, and this E entity with an entity B as well as C. So the intermediary relationships we are putting as RA, RB and RC. So this is the conversion from a ternary relationship into a binary one. So this is a binary relationship. Okay, so this is how the binary relationship is formed from a ternary one. So this was a ternary representation. So ternary. So this is ternary to binary representation. Now converting non-binary relationships to ternary, that we already come to know about. So let's move forward. The year design decisions. Now this is very important part. The use of an attribute or entity set to represent an object, and the real world concept is best expressed by an entity set or a relationship set. So the use of strong and weak entity set is very, very important here. The aggregation relationship that we can put in the diagrammatic representation of ER model. Now this is the summary of symbols used in ER notation. We have already used this entity for rectangle. This is the relationship set. Double rectangle, double rhombus is representing the identifying relationship. Basically this is used in weak entity set representation. Double line represents the total participation. Here these are different attributes of one level. This is another level of attributes, that means sub attributes, that this is the main attribute and which is decomposed into sub parts. Basically A2 is a composite one. Here it is. Now coming to the symbols used in year notation, this is the many to one, many to many representation or relationship. This is one to one with the arrow, and that can also be written like this. This is another representation type. This is role name. Every relationship also has a role indicator. So with a small box with the relationship, we can indicate the role. Let's say, for example, there is an employee which has a specific role that is called manager. So the role can be indicated like this. Now there is something called ISA relationship or generalization, like this is a student, this is a employee, and this is person. Okay, so student is a person, employee is a person, so this is an ISA relationship, and we can call it as generalization or specialization. The downward is the specialization and upward is the generalization. This is person, this is, let's say, employee, and this is student. Okay, now this is another representation, disjoint generalization, and there is something called overlapping specialization as well. So we have already discussed that. Now alternative year notations, here we can see different types of year notation is there. For weak entity set, this is the representation of weak entity, double rectangle. This is the generalization, this is total generalization, where you can see double line is there, and this is A1 is a primary key, simple attribute. A2 is a composite attribute because this attribute again further has a set of attributes, sub attributes. So this is A2 is a composite attribute. A3 is a multi-valued attribute, double ellipse. A4 is derived attribute that we already discussed previously. Now these are two different models of notation. One is Shen model, another is crow's feet notation. So in the Shen model, many to many representation is like putting a star both side, and in crow's feet model, like crow's feet, you see here it is like the feet of the crow. So that is why many to many is represented like this, but if there is only one to one, then nothing is there, and this is again many to one, and that in Shen model it is represented by star, it means many, and if it is one, that means we are putting a numeric one. Total participation is denoted by double lines in the Shen model, whereas in the crow's feet model, there we put a hollow circle. You can see here a small white circle, and where there is a not total participation, there we block it with a this bar. So left side is total participation and right side is that total participation is barred. That means that is very normal type of participation, that means partial participation we can say. So this type is partial participation and this side is total participation. Like here double line means total and single line means partial participation. That's all. Now there is something called UML, Unified Modeling Language. So if we know about year model, we should also know that where this year model is actually. So UML is having many kinds of diagram, like state chart diagram, event flow diagram, workflow diagram, year model, DFDs, and so on, so forth, use case diagram. So out of those 12-13 varieties, year diagram is also a part. Now this is the comparative study between year model and UML class diagram. So UML is a separate subject that if you wish you can learn in another time, but here you need to concentrate on all the year diagram representation. So that is given here. And this is also all the similar kind of representation which are there in year diagram. UML representation are also put on the picture here, and this is UML class diagram representation that we have already seen just in the last slide. This is a detailed year versus UML class diagram representation, just for your reference. But the left side of this red vertical line, these are the year diagram notations. These things you have to note. The functional requirements are the other aspects of database design, data flow, workflow, etc., and schema evaluation. With this, we conclude. Thank you so much for your patience to listen me. We will meet in the next class.